to present a new bridge management system for Slovenian highways, which we started using this year. So, as this seminar is intended for a truly international audience, I first have to put Slovenia on the map. Our country is located in the Central Europe with an area of approximately 20,000 square kilometers, which is about the size of El Salvador in Central America. The country has a population of about 2.1 million. Although small in size, there are three European transport corridors passing through Slovenia: the Mediterranean, the Baltic Adriatic, and the Pan-European corridor. Now, as you can see, the state of our transport infrastructure can indirectly affect the economy of many European countries. Now, in the picture on the right, the highways are marked with the purple lines, and they can directly correspond to the corridor shown in the previous slide. Now, the length of our highways is around 600 kilometers, and there are approximately 1,200 bridges on these highways. Just for comparison, the length of our state roads is about 6,000 kilometers, and there are about 1,400 bridges on these roads. So this was a brief introduction of Slovenian road infrastructure in general. Now let's move on and take a look at our bridge management system development. Now, the construction of Slovenian motorways started in 1970s and then got a real boost after 1995 and was more or less completed in 2010. Now, by that time, the first bridges in the network were in use for, let's say, about 40 years. There were not that many of them, and everything could still be managed by hand. Then, every year, more and more bridges were in need of some sort of investment, and it became increasingly difficult to manage everything just by Excel. So, from the time we identify a deficiency on an individual bridge through the process of public tenders and for documentation to be made and contractor selection until the end of the rehabilitation works, a few years normally pass. That is why the highway authorities wanted to know in advance which bridges will be in need of renewal in the future, so they have time to prepare. Now, additionally, if you know which bridges are about to go from good to bad condition, you can also perform preventive maintenance. So in 2016, a need for a bridge management system was expressed, and the very next year, the development started. Now, in that period, a European project standardizing bridge condition assessment was launched, which helped our development a great deal. The association is now called Eurostruct, and I'll talk more about that during next slides. So here we can see an overview of the systems framework. Now, don't worry, we'll take a look at the individual parts of this framework during next slides. Now, number one, we have performance indicators. They tell us in what state an individual bridge is at the moment, or let's say this year. Now, performance indicators are, for example, damage, load-bearing capacity, and similar. For us, knowing their present state is not enough. Like future performance indicator values need to be determined for every bridge in the network. Now, this is, in my opinion, the most demanding part of any bridge management system, to determine the future condition of bridges. Under number 3, we have a catalog of measures, and I'll show you the details regarding the measures on next slides as well. Now, for every measure on every bridge, costs and their effects on performance indicator, basically these are benefits, need to be calculated, regardless of their actual implementation. Because at this point, we do not know which measures are going to be implemented. Now, with inputs 1 to 4 available, measures which meet certain, let's say, requirements, or we call them triggers, are then generated. This is 5. Now, this is the end of the system structure level. So by this point, we gather almost all the data we need: the breach present condition, the future condition, the possible interventions for each breach, the cost of their implementation, and the benefit of their implementation. Now, next, we'll go to the network level. At the network level, the decision is made as to which interventions will be performed in a particular year. First, need a target function. It's used to calculate the total benefits of various sets of rehabilitation measures. We also need a budget constraint. It basically tells us how much we can spend every year. So this is under 7. I'll also explain these 2 elements in later slides. Now, with inputs 5, 6, and 7 available, the cost-benefit analysis is performed. The analysis actually calculates the total cost and benefit for all measure combinations, taking into account the yearly available budgets. We use software called Data on Total Infrastructure Management System to do that. At the end, the set, the combination of measures which with the highest value of the target function is the optimal one to implement. So here we get the results. Of course, in reality, we perform analysis under different budget constraints and different measurement constraints just to simulate different scenarios. Because by doing that, we get a better understanding of the highway's present and future state, depending on the future investments. So now we'll look at each breach management system individually. First, we look at the performance indicators and their future values. Now, the performance indicators can be any indicator that describes the state of the breach. They are very diverse by their nature, and their values are normally further used to calculate the values of so-called key performance indicators. So now I'll go on to set a few examples. So for example, we use the data regarding pavement damage and safety equipment damage to determine the value of key performance indicator user safety. Load-bearing capacity, traffic flow, possible restrictions for pedestrians or high trucks or similar are used to determine breach availability. Now, if the availability, for example, is poor, we have a low load-bearing capacity, it might make more sense to build a new bridge than trying to reconstruct and reinforce the existing one. I also talked a bit more about that during the next slides. Now, the key performance indicator reliability is the most important indicator in our or in general any breach management system. With it, we assess its value based on damage recorded during periodic inspections. Now, we are not interested in general damage. For us, it's also important which structural part has a certain amount of damage and where the damage is located. Now, for example, if a 1 millimeter transverse crack is located in the middle of the span of the superstructure, the breach structural safety could be questionable. However, if the crack with the same width is located at the breach abutment, it's not really a serious damage, and there's no need for it to be repaired immediately, of course. Now, it is also not the same if there's a certain extent of corrosion recorded on the superstructure of a small reinforced concrete bridge, which structural design is very robust. Or if the same damage is recorded on, let's say, a superstructure of an older, longer precast bridge. So these are all factors affecting the bridge structural safety and with it reliability. Now, the subject is really demanding, and it took a 4-year European project to define everything regarding assessing the individual bridge state. You can find out more about that or regarding the subject on the internet site Eurostruct, and then go under the file repository box. You can check work group 3 and work group 4 final reports. Of course, you can also check other literature. So as I mentioned earlier, it's not enough to determine the present or the current state of the bridge. A forecast of the bridge condition has to be made. Now, the forecast has to be done for every performance indicator in order to get the future value of the key performance indicators and the bridge state in general. Now, as I mentioned before, in my opinion, to get this right is the most demanding part of any modern bridge management system. Now, on the top diagram, you can see a forecast of a bridge performance over time, which is, of course, worsening. In the lower diagram, a bridge performance with a complete rehabilitation planned in 2030 is shown. Now, here a new dilemma arises. How do we determine the most suitable time to perform a certain rehabilitation measure on a certain bridge? Now, first of all, we need a catalog of measures. And each measure is defined by the following. The type. In general, does it affect the whole bridge or just a segment? If we are looking at the railing replacement, we are only interested in the state the railing is in. The other thing is measures triggers. Which conditions must be met for the implementation of an individual measure? For example, to demolish an existing and build a new bridge, the existing one must have, in addition to high damage, also a low load-bearing capacity, let's say due to its structural design. So its reconstruction and reinforcement is not really a feasible option. So on the other hand, drainage replacement has a more straightforward condition. If it is damaged enough, it meets the condition of its replacement. The performance indicator reset values, that's the third thing, are determined for every performance indicator affected by the implementation of each and every measure. I really do not have enough time to go into detail regarding that subject. Now, the measure's benefits are determined, as we can see on the diagram on the right. A benefit is calculated as an area between the do nothing target function curve and the implement measure curve over time. And finally, the measure's costs are defined either in percentages of the value of a new bridge for major measures, let's say for superstructure renewal, or in prices per unit for smaller or minor measures. Example, expansion joints replacement. So now we know everything regarding the bridge, its current and future condition, its possible rehabilitation measures, together with costs and benefits they provide. Now, the next step is to compare and prioritize bridges and their measures for the entire period analyzed. And we do that on the network level. And the network level is marked with numbers 6 to 9. First, the target function. This is an element whose value we are trying to maximize, and the budget is a cost constraint, an element that limits the target function value optimization. So let's take a look at that. Okay, so maximizing the average breach condition of the breach stock is the road authority's goal, of course. Now, the user's goal might not be exactly the same, as for them, it's also important which bridges are in good condition and which are in bad. Now, bridge in a good condition and a high daily traffic is certainly worth more than a bridge in the same condition and low daily traffic. So in order to take into account the user's benefits, the parameter of average annual daily traffic is embedded into the target function. Now, as AADT, or the average annual daily traffic, values vary greatly between bridges, the value is under the third root to limit its influence to the calculation. Now, bridge floor area is also, or actually needs to be used in the calculation, as large bridges cost more to repair, but the benefit of their repair is also bigger, as they pass greater obstacles or they have more lanes or similar. So the target function equation is displayed on the left side of the slide. On the right side, it's the budget constraint. Now, it can be either the same during the whole analyzed period, as it is shown on the slide, or it can vary every year. In general, it stays more or less the same, but when performing analysis, we can change it just to see what happened. Just a reminder, the discount rate and inflation rate also need to be considered when we are defining budgets. Okay, so as already mentioned in the beginning of the presentation, we use software called Dayton Total Infrastructure Management System to perform a cost-benefit analysis. There is, of course, other software available to do this analysis, and I would say that up to 100, maybe even 200 bridges, a bit simpler analysis could even be made using Excel or Access sheets alone. I will not talk about the software itself. We'll just take a look at the results. So here are different results we might get. So our breach management system provides a variety of data. For example, on the left upper corner, network average condition through the analyzed period. Then we can also see on the bottom left side ratios of individual performance indicators and key performance indicators on the network level also over time. Of course, what the authorities need most is, of course, the construction plan for the whole network. And the table in the upper right corner is filtered in order to show only the bridges in need of, let's say, total reconstruction, and we can also see the year the reconstruction is planned. And on the bottom right corner, we see an individual bridge plans where we can see the cost of the individual measure to be implemented. Now, of course, all results depend on the cost or constraint, let's say, on available budget. If the budget is low, the performance indicator values worsen and the network average condition worsens, and so on. So this is the second to last slide. It is intended for a summary of our bridge management system and bridge management systems in general. So all systems have to be divided to a structural and network level. On the structural level, we have to define which performance indicators we will use. We can only use the ones for which we can determine their present and future values for all the bridges in the network. Because obviously, we cannot analyze bridges for which we do not know in what state they are in. And the other thing we have to define is the possible rehabilitation measures and their costs. Now, on the network level, we have to define constraints, which actually mean yearly budgets. So this is not really demanding. And we need to perform some sort of analysis, either life cycle cost analysis, cost benefit analysis like we do, or some similar analysis. Now, the easiest way to do that is, of course, to have a suitable software. So, to conclude, the system presented compares the condition of all bridges in the network, generates possible rehabilitation measures for every bridge. It compares their costs and their benefits using cost-benefit analysis. By doing that, it actually optimizes the use of financial resources, and it provides the predicted future condition depending on different budget scenarios. So that's it, and thank you for your attention.